Good afternoon, and thank you all very much for joining us on this session. We've split this presentation into two distinct parts. In the first section, I'm going to discuss the implication that COVID has had on the design and operation of ventilation systems. And in the second part, my colleague Thomas is going to discuss the sort of wider challenge that faces us all at the moment in terms of the reduction of carbon emissions within the built environment. If I may, I'd just like to give a very brief introduction to us for those of the audience who are not familiar with Cundall. We are a practice of multidisciplinary consulting engineers, originally established in the UK, but we now have global coverage with offices across Europe, the Middle East and the Asia Pacific region. We do work across all areas of the built environment and all sectors, but we do have a very strong track record and a strong experience in the sport and leisure industry. Our pool portfolio extends to over 100 projects, which vary from new build projects through refurbishments and surveys and studies and reports on existing buildings. So that's us. So in terms of ventilation, there has been quite a lot of guidance published and recommendations provided by a number of bodies over the last 12 months. This has included documents from CIBSE, from the Health and Safety Executive, from the Environmental Modelling Group of the government's SAGE organisation. And in fact, PWTAG's own guidance notes have included some recommendations in terms of ventilation requirements. I've tried to capture here some of the main points that have been drawn out the various guidance documents. Firstly, a lot of emphasis has been placed on the use of natural ventilation where possible. Secondly, avoiding recirculation of air where possible. That's avoiding the mixing of the return air stream into the fresh supply air, and also looking at local units such as fan coil units, which can recirculate air locally in spaces. The possibility of increasing fresh air ventilation rates. Current standards for the likes of schools, office buildings, etc. Generate a figure of between 8 to 12 litres per second per person, depending on the standards that they're applying. Talk is of increasing that to the region of 15 to 20 litres per second per person, and also reviewing types of heat recovery system. So how do we apply this guidance particularly to swimming pools? If we take each point in turn, maximising natural ventilation is difficult in a pool. Particularly with an existing building, they are generally designed to be mechanically ventilated, and the opportunity for opening windows, etc., are likely to be very limited if exist at all. The other issue with using natural ventilation in swimming pools is firstly, the implication of energy, and it certainly wouldn't be able to be used for large proportions of the year when temperatures externally are low. And the other issue is controlling condensation. It introduces another difficulties to that. Avoiding recirculation of air. Well, a lot of pool systems do actually include recirculation in the primary plant. It's there as an energy reduction measure when full fresh air isn't required in order to control temperature and humidity levels. It should be able to be easily reconfigured in terms of the controls to avoid the recirculation and operate in full fresh air, although it has to be noted that there is a potential energy implication with this. If we're full fresh air in winter, it's obviously going to take a lot more energy to warm the air. The third main area of guidance relates to increasing ventilation rates in buildings. This is interesting in relation to a pool hall. Without getting too techy about how we design ventilation systems, a reasonable rule of thumb would be to consider a ventilation rate of between 10 to 15 litres per second per metre squared of wet area. Now, if we took, let's say, for example, a 25 metre 6-lane pool, at the lower end of that spectrum at 10 litres per second per metre squared, that would give us a ventilation rate equivalent of 40 litres per second per person if we were to assume bather occupancy or bather density of 1 person per 3 square metres. Equally, if we went to the upper end of the scale of 15 litres per second per metre squared, that would give us 60 litres per second per person. Now that, if you think back to the 15 to 20 litres per person for other types of buildings currently recommended, that's already 2 to 3 times that ventilation rate. And that could be, given sort of plant reconfiguration to be full fresh air, that could be all fresh air. The other thing to factor into that is assuming a bather density of 1 person per 3 square metres. And there has been discussion recently that a safer level in the current climate is to look at a bather density of 1 person per 6 square metres, which increases the margin even further. And the final area is heat recovery systems. Most, if not all, swimming pool ventilation systems will incorporate some form of heat recovery. The two most common types, plate heat exchangers. It's fairly straightforward. 2 separate supply and exhaust streams completely separated by solid plates. So there's absolutely no risk of contamination in that type of system between the exhaust air and the fresh air supply air. The second type is a rotary thermal wheel. A little bit of a risk in terms of return air. They're not designed to mix air, but there is a section where the wheel rotates where there may be a very minor carryover of air from the exhaust to the supply. Fairly low risk of cross-contamination, and probably the energy implications of switching these systems off and not running them probably far outweighs the risk of carryover from the return air. So where does that take us? Pool halls, good levels of ventilation, generally way in excess of minimum recommendations, and we'd consider to be fairly low risk as they are currently designed and operated. Similar for changing rooms, generally very well ventilated, usually 100% fresh air, fairly low risk. Spectator areas, normally part of the pool hall, so part of the same ventilation system, and in the current scenario, unlikely to be in use or certainly with restricted occupation. So the one area we haven't touched on is fitness rooms and studios. We often see, particularly in existing buildings, examples of fairly low levels of poor ventilation and local air conditioning units which can recirculate air locally, and also fairly high densities of occupation. So those are the one area that we think, particularly in existing buildings, warrant further study. So thank you very much. At that point, I'll hand over to Thomas, who will talk about the carbon challenge facing us all. Thank you.
Thank you, Kevin. My name is Thomas Neeson, and like Kevin, I'm a mechanical engineer with 25 years of experience in designing all sorts of leisure buildings, lots of them with Kevin on pools and other facilities. And I wanted to talk about what happens after COVID. I know most of the conference is on COVID, but there will be a day we don't have COVID, and then we'll have something even bigger to get our teeth into, and that is delivering net zero to meet the climate emergency that we have. We need to reduce our carbon emissions. We need to limit global temperature rise because of the impact it's going to have on climate, our habitats and biodiversity, and we need to reduce our consumption of resources. The graph we've got here on the bottom left indicates how we can increase our renewable energy production going forward towards 2050, and how we must reduce our energy consumption to match this. This is what net zero is. It's not using any energy. It's actually making a balance between what we can sustainably generate and what we use. I've highlighted some publications on the right because some guidance is available in this field and we can help on this. So we're at the start of a journey, but there's information there and lots to read up and go with. But the net zero challenge for pools is sort of a fairly unique one because we have large bodies of water and air that have to be maintained at high temperature. And also we need large volumes of water for hot water for showers. So we've got a heating requirement to cover evaporation losses, and most of this heating is produced by a high carbon content natural gas. So the question is, how do we reduce this energy consumption and thereby the carbon content of the energy we use? There is guidance available here again, and saving energy in leisure buildings is nothing new. So there's guidance published on the right by all of the relevant bodies, and now we're getting guidance from, for example, Passive House Institute, which can take us a step further, and we'll come on to that. So how do we tackle this myriad of challenges that we've got in trying to reduce our impact? We've come up with a plan that is a circular plan. There's steps on the path. It's not linear because the idea is you go around the path, and then when you get to the end, you've learned a lot to put back into the projects that you start next time around. And I'll go through these steps one at a time in this presentation. The first is passive design optimization. So we're saying really in a pool, because of the volumes of energy that we're holding, we want to reduce the total water volume, what we can get away with. We want to reduce the air volume, look at the height of our pool halls, limit our area of glazed areas, look at the thermal performance. And if you look on the right, the diagram indicates sort of a sensible approach from passive house, which is make your thermal performance as good as possible, reduce the air leakage, then you won't need to pump as much air around, you'll be able to run higher humidity without a risk of condensation, we can have less evaporation, and all of this adds to low energy. The picture on the bottom is the first passive house pool that's been delivered in the UK. It's not one of our projects, but it's a very, very good project delivered in Exeter. And the building here, the enhanced measures to achieve passive house will pay back in less than 10 years. But during that time, the building will have significantly lower carbon emissions than comparable buildings, and that will carry on for the 25 or maybe 60 years of its life. Less energy being used and consumed all the way through the life of the building, and therefore lower carbon emissions. A good benchmark for projects going forward. Step 2 is to reduce the operational energy, and with the operational energy, this can apply to both new and existing facilities. Obviously, there's many more existing facilities. And we've listed a number of details on the left of what initial steps might be. None of this will be new, and people will be familiar with some of it before. And we find when we go to look at existing facilities, it's the operation of the controls, the time schedules, and the operator's knowledge that are usually the things we need to pick up on, and savings can be made just by getting the installed systems to run properly. Then you can build on those and enhance them with variable speed drives, with LED lighting, pool covers we'll not talk about because we could spend all afternoon on that. And there's new technologies like heat recovery from showers. The diagram on the bottom right in the picture shows how this can be incorporated, maybe more in a new facility, but it could also be looked at if you've got a basement below your shower areas, because a lot of energy is wasted at this point in a pool. Steps 3 and 4 go in conjunction, and these are eliminate fossil fuels and provide on-site renewables. So again, what we're trying to do here is reduce gas. The diagram on the bottom left indicates the carbon content of gas in the red line, which is constant, and the fall in carbon content of the electricity grid due to the input of renewables over time. So in due course, electricity will have a carbon content of less than a third of gas, hence the drive to electrical solutions. So CHP has been popular. It's good because it generates electricity at the point of use with no losses, but obviously it still uses a fossil fuel. We can use on-site PV or maybe wind turbines, and pools are good schemes to do this on because of the large areas of roof available. If this can be combined with, say, battery storage, all of the energy produced from the sun on a pool site can be used on the pool site. And we'll see a conversion to air source and water source heat pumps to maximize the use of the electricity at the point of use. The little green diagram in the middle indicates that for every kilowatt you can generate from your wind turbines or PV, you can get effectively 3 kilowatts of heat or cooling from your air source heat pump. Solar hot water is another good technology, quite often misunderstood and quite often installed on pools and then switched off because people don't understand how to maintain it or run it. But with a little bit of training, it can be another good source of, if you like, free energy and carbon-free energy. There are incentives to help us do this. The UK government has provided a fund of £1 billion, which was spent within 12 weeks of launch to allow the public sector to decarbonise their projects. The money is being handed out. 2 councils we've been working with, local authorities, one has secured £11 million of funding, one has secured £4.5 million of funding. And this is going to ultimately leave 9 swimming pools taken off the gas grid and able to run on electricity alone, enhance their renewables and decarbonise. Step 5 then is to limit upfront embodied carbon. So we said in step 1 we need to optimize the design, minimize the material content. Then you've got to look at what the material's carbon content is. Timber's a very good choice. Lots of historic use of glulam has been made in pools for lots of good reasons. And now we're seeing CLT, cross-laminated timber, and structural solutions in pools as well. All adds to reducing the carbon content of the buildings that we build. And go into step 6 and 7, and then we go back around the cycle again, as we've said. So in conclusion, on Kevin's part of the talk, we're saying in ventilation and COVID in pools, the pool hall may not be where the issue is because these are generally well ventilated. We'd ask people to look at their fitness and studio areas to check that there's actually mechanical ventilation and not just cooling in those areas. And for all areas, check the cleanliness and filtration of your systems. And in terms of the further net zero challenges that we've got, we need to focus on carbon reduction, and that goes hand in hand with energy reduction. There's lots of ways we can reduce energy and the carbon impact on your pool, whether it's new or existing, and we can take that forward. And there are generally easy wins if we have an operational review and look at the controls and how to optimize that. And also to help along this, there are funding routes available. I didn't mention it earlier, but there are parallel European schemes as well as the UK government schemes into decarbonising buildings. And I know we've been involved in a few in Ireland currently to access that funding also. So I hope that's been informative. It's been a bit of a whistle-stop tour. We're quite happy to answer any questions that this might have raised, or any questions you've got about these topics. So if you'd like to join us for the Q&A session, we'd be most pleased to try and help you. Thank you.